All right, MiniExam 2 demo. Here we go. So as always, I'm just going to start with my name. So put my name at the top. I don't have a student ID, but if you had one, you would put it here. And then just the standard academic conduct code kinds of things. All right, so the way we work through these, I've written these questions, but I haven't gone through and solved them yet. We're just going to do that together. So for question one, we're going to look at these three data sets in our data tables over here. For each data set, identify the variable types and draw the most appropriate part two visualization. So it's asking for visualizations, from part two and identifying the variable types. For data 1A, these are restaurant tips by meal type. So here we have customers, so this is our index variable, and then here we have a categorical variable. So this is cat, and then this is a numerical variable. So numerical, and then so here we want to describe the variable types. So this is categorical and numerical. Okay. And then we're trying to visualize this data set. So here I have a categorical and a numerical. This is a great, application for a multi-box plot. So I'm just going to set this up. Horizontal axis will have the meal, and then the vertical axis will have the tip. And then we'll just have, our box plots. Something like this. And then if we wanted to add a strip plot, we could do that too. Okay. So then for 1B, and we've just gone through, we've made sure we've labeled the axes and then shown exactly what we're doing. So for B, this is data 1B. So this is house size and price. So here we have our index variable, we have our numerical variable, and then we have our other numerical variable. So here, this is a classic example of a scatter plot. So here is, we'll just say numerical by numerical. You can't really read this. Ideally, this would have more space, but yeah, I think for the solution guide, let's actually write this out nicer. So this will be cat by numerical, and then this will be numerical by numerical. Okay, so here we have two axes. And for this question, it doesn't matter which is which. We just want to specify that one is one and the other is the other. So let's put square foot. And on the vertical axis, we'll have price. We're good economists in putting price on the vertical axis, as is the convention. And then, so let's see here. So then we just have, our scatter. So something that looks like this. Data tables 1C. So this is not laid out well, but here we're looking at study hours, GPA, and major. So I'm going to flip the table over. And here we have our 1C. So here we have student. So this is just an index variable. We have major, which is a categorical variable. We have study hours, so this is a numerical variable. And for GPA, this is also numerical. And I'm realizing I'm being a little imprecise here for the subtypes of categorical and numerical. This is categorical nominal. These are not ordered. And then study hour, this is numerical, and then this is in hours. So this is, even though it's listed as integers, this is a continuous measure. because you could list 1.3 hours. So then here, GPA, this is also continuous. Okay, so we have our index variable, we have all three of our variables, and we can just list these out. So here we have a little bit more room. This is cat nom by numerical continuous by numerical continuous. Okay, so then for this one, we have three different variables, and what that means is, we could actually plot out the relationship between the two numerical variables by category. So in this case, we'll have a bivariate scatter plot, but we're going to have multiple groups. So here we'll have maybe study hours, and on the vertical axis we'll have GPA. Okay, and then so we have, let's just make this look nice. So let's say we have one group up here, and then maybe we'll do this in circles. We'll have another group down here. Okay, so we have our two categories of bivariate relationships. That's very nice. So then for question 2, fix the figure. There are 3 data visualizations, and each one has a problem, and we're trying to fix it. Okay, so the way we'll do this, we want to clearly label and make it clear what the improvement is. So I'm just going to go through these. So for A, on the vertical axis, I have revenue, and then the horizontal axis, I have years since founded. So this is not a variable that would be easily skewed. This is just time. But the vertical axis, this is actually one that it looks like there's a scaling relationship. So it's getting skewed upward. So maybe over time, the company is doubling its revenue every couple of years. So we'd actually get a scaling. So in this case, all I need to do is just plot log revenue on the vertical. So this is years. And then the vertical axis will just be log revenue. My handwriting is horrendous. Look at that. And then that's actually going to show up as if this is truly scaling, then this will show up as a linear relationship. Okay, so here we're logging the vertical axis. So for this one, let's take a look at what's going on here. So the problem is that we get a lot of data. Maybe this is sort of hard to see in this figure, but we get a lot of data around 0. One thing we could do, is maybe clip the top and just look at some of the lower values. But here you can see this is home price. And so it turns out whenever we're dealing with prices, this is a classic example of applying a log. So just like this first one, let's apply a log. So here we'll have log prices. So log price, P, our ice price. And then we'll have region A, region B, and region C. And if this is done correctly, then we'll end up with box plots that look much more reasonable. Maybe the second one is a little higher, and then the third one maybe higher yet. Okay, so something that looks like this. Nice. So then for the third one, here we have company size, and then on the vertical axis we have revenue. And it looks like we have a lot of data that's clustered around 0, and then we have some of these larger values that are skewed. So in this case, both company size and revenue have this skewed property. So both of them are scaling. So it's very unusual to have very large companies, and it's very common to have very small companies, just like incomes. So let's set this up. We'll have both log company size on the horizontal axis, and then on the vertical axis, let's set up log revenue. So this is a log-log relationship. And this is, just like we've done in class, this is very classic to have two scaling axes. Okay, so nice. So it should look something like this. It pulls out the variation into small and then sort of compresses the variation into large. All right, so this is the first two questions, lots of figures. So for question 3, we actually don't have any data table. So we're asking a couple of multiple choice questions here. So a 1 unit increase in a log base 2 will increase by a double. So it's going to double every time. So it's increasing by, we're multiplying by the base every time we move on the horizontal axis, or whatever the axis is. So every time we increase by one of these tick marks on the horizontal axis, we're multiplying by whatever the base is. Okay, so in this case, we can just rule out the others. This is, we're going to double every time. All right, so for then B, on a log base 10 scale, each 1 unit increase means the original has what? Well, again, we're increasing by 1 tick mark on the horizontal axis. So on this scale, we're increasing by 1. What does that mean for the actual original value? Well, in this case, we're increasing by a 10. So we're increasing by a factor of 10. Okay, and then for C, product A has log 2, 1 plus revenue, is equal to 4. And product B has log 2, 1 plus revenue is equal to 7. The difference is 3 units. About how many times more revenue does B have than A? So here we can just write this out. So we have this little funny thing going on here with 1 plus. It's asking for about, so we're not actually going to need to handle the 1 plus. But let's just draw out some values here. So let's say this is 4, this is 5, 6, 7, and we're wondering how many, so this is a difference of 3 units, about how many more times revenue does B have than A. So every time we increase, we're increasing by a product of 2. So this is 2 every time. So this is 2 times 2 times 2. So this comes out to be 8. So in this case, it's going to be roughly 8 times. It's not exactly, because we have this 1 plus, but this is, yeah, about 8. Okay, so for question 4, we're investigating and visualizing, and we're going to use data 4. So this is non-profit shift records. And then again, unfortunately, it's on the opposite piece of paper. All right, so let's look at this. So we have a nonprofit that tracks shift data for its volunteers and employees. And then we have our data set here, which shows each person's role. So we have role here, and the day of their shift. So here's the day. And then how much they made during that shift. Okay, so you can see if you're a volunteer, you're unemployed. You're making 0, unpaid. Okay, so what we're going to do is try to visualize the shift pay, and we're going to do this grouped by day, using all the data in 4, data 4. So this is going to be every data set, or every row. And you can see we have 2 kinds of days. So we're asked to group by day using the data. And here we have, we're not asked to do anything with role. We're just visualizing by day. So we're asked to visualize shift pay grouped by day. So one way we could do this, we could just calculate the average or the summary statistics for shift pay broken out by day. But I think a better approach would be to actually plot the distribution. So this is one of those classic distributional questions. So the horizontal axis, I'll just plot day. So we'll have weekday, and then weekend, and then on the vertical axis we'll have shift pay. We'll just call this pay. And then we just have our box plot. So it'll look something like this. Looks something like this. Okay. And what you'll notice here is we actually have a lot of zeros. One thing I think this question could be improved, like on my end, is to ask to be as specific as possible. We're actually going to have a lot of zeros here, so this is not what the distribution will actually look like. We'll actually have a lot of zeros, so it could look something like this, much like what we saw in class. So this is a lot of zeros. So the 25th percentile is equal to the minimum. Okay, that's a terrible figure. Maybe I don't know if this will improve it or make it worse. Okay, for this second question, we're asked to visualize after we've filtered for employees only. So we're actually going to strike out all the volunteers. And we're going to look at only the people who are employed. And then we're supposed to plot that. So in this case, we're asking, to sort of contrast these two figures. So here we have weekday, and then here we have weekend. And once we've gotten rid of the zeros, this is actually going to change the distribution. But the intent here, once we remove the zeros, the box plots actually shift up. We're no longer, including these zeros near the bottom of the distribution, pulling everything down. Okay, so nice. So here we have our two box plots, one with and one without the zeros. And I think this question could be improved to communicate that intent a little better. So let me just write something in. Maybe we just say, show how the distribution changes after the filter. So then our last question here, we have interpreting a scatter plot by category. So here's our last question. So here we have a nice little figure here, and we're asked these three questions about it. So first, as study hours increase, what happens to exam score for online students? So here, this is very unrealistic looking data, but we have online students who are darker. So this is, let's label this. So this is online. They're a little bit darker. And then the lighter one is in person. Okay, so here we have our two groups, and we have our two data points, two sets of data, and then a line of best fit going through both. So as study hours increases, what happens to exam score for online students? Well, we can just say as study hour goes up, so we move on the horizontal axis, what happens to the vertical axis? Well, it goes up. So exam score increases with study hour for online students. Nice. Okay, so relatively simple. Really just interpreting what the figure is telling us about the subgroup. So then as study hours increases, what happens to exam score for in-person students? So here it also increases. Exam score also increases with study hours for in-person students. Okay. And then, so which group benefits from additional study hours? Benefits more from additional study hours? Well, so we can't say anything about causation. But what I infer from this question is that we're asking which group has a stronger relationship between study hours and exam score. Um, so I would say in-person students have a stronger relationship between exam score and study hour. Okay, so this is not a comprehensive list of all types of questions to expect on MiniExam 2, but I think this gives you a good indication of the kinds of questions I'm asking and the kinds of skills I'm looking for. Really, this is about interpreting figures. It's about choosing a visualization type for the data set that you have at hand. It's about fixing some of the problems that we commonly see with figures that make them difficult to interpret. And then interpreting logs, and then doing some filtering, and then we also did some interpretation of figures too. All right, so I'll see you all in the next one.